welcome to our webinar. Many thanks for joining us. I'm here with Nathan Lawrence.
Hiya.
And we've got Matt Blackwell, who you can't see. He's doing all the IT, so if it goes wrong, we've got somebody to blame.
Exactly.
I should tell you that the webinar's being recorded, and also, if you have any questions, please write them in the Q&A box at the bottom of the screen, and we'll get to them. We'll save some time at the end to go through all the questions. Perfect. So I've got a few PowerPoint slides, not many, you'll be pleased to know, but a few. So this is the agenda for today. We're going to tell you about how the sensor works, how it can possibly be calibration free, and then explain the transducer, which is kind of the main part of the sensor, and talk a little bit about how our solution is different to that of the glass pH probe that you're mostly familiar with. The main part of the webinar will be a demo, so we're going to show you the connections, the utils program, all the menu functions of the sensor, talk a little bit about the output string, the abrasion, the transducer replacement, and the user interface. And then finally, we've got some discussions on the integrations that we've done so far, the future plans we've got for the sensor, and then just give you some information about where you can find more info and how you can purchase the sensor. Okay, so we'll jump straight into how it works. Maybe Nathan, you can go into this?
Yeah, for sure. So when we first started A&B Sensors, we went to speak to glass electrode manufacturers, end users and deployers of the pH sensor and try to understand why glass electrodes need to be recalibrated during deployment. Overwhelmingly, that response came back to say it's all around changes in the reference electrode potential over time. Therefore, the sensor needs to be recalibrated, the glass pH probes need to be recalibrated to track that drift or compensate for that drift. If we look at our plot in the top left here, you can see after 10 hours, there looks to be a change in pH. But is that really a change in pH, or is that a change in the reference electrode potential? And that's the question we ask ourselves at A&B. Within our sensor is a transducer, and this is the major part. All the working elements are inside the transducer. The transducer contains a reference electrode tracker, which tracks the reference potential of the reference electrode in real time and without end user intervention. You can clearly see in the plot, after 10 hours, there's a change in the reference electrode potential. Combining this measurement with our pH sensing electrodes also found on the transducer, we get a calibration-free pH sensor, and therefore it never needs recalibrating for changes in reference electrode potential. From this, we can get a pH range from 2 to 10, accuracy of 0.05, and a resolution around 0.01 pH units. Today's version 9 firmware, which is released on the website, covers a range 0.3 to 40 ppt. All our sensors have inbuilt temperature sensors as well, and we have an instantaneous response to changes in pH, which the sensor picks up on. Through having a reference electrode tracker, we actually provide a second output. We can provide salinity, from which we can mathematically calculate conductivity. The salinity, pH, temperature, and conductivity are therefore all calibration-free measurements directly from the sensor.
Brilliant. So now shall we have a look at the sensor and the menu functions? Maybe you can just talk a bit about how it's different from the glass electrode.
Yeah, for sure. So obviously, our sensor is all solid state. Some of you would have seen this before. It's made of plastics. You can drop it. It won't smash like a glass electrode. Doesn't need to be stored wet or dry. It can be stored wet or dry. Doesn't need to be stored wet like a conventional glass pH electrode. And it's solid state and robust. It's also smart, has inbuilt memory functions, and we'll talk about that as we go through the webinar today. If we're going to look at how we connect the sensor and really set up the sensor, you can do this through the computer using our A&B utils program, which Kay will demonstrate in a minute. We supply data transfer units, which simply convert a 232 signal to a USB signal and also power the sensor through the USB port of a computer. In the case here, this is our OC300. It comes in a subcon connector system, and we can plug a subcon connector straight to the sensor. We supply a range of sensors. We have our OC300, which is rated 300 meters, and 1250, which is a titanium version, rated at 1250 meters. AQ50, which is 50 metre rated, and a 5 metre rated version as well for shallow water and river monitoring. The 5 and 50 metre rated will come with pigtail cables, or 6 pin pigtail cables, 2 for power, 2 for 232, and 2 for 485. If you supply a DTU with these pigtail cables, we supply a converter cable, really just to plug directly onto here, and then can be plugged directly into the data transfer unit. Once we've connected the sensor, we turn on the data transfer unit. The sensor will be twice on power up, and we can connect to the utils program, which Kay is going to show to you now.
Okay, perfect. Thank you.
It's always there somewhere.
Keep talking, Nathan.
That's okay.
There you
go.
Okay, so this is the utils program that you can download from our website. Once you download it, you just need to unzip it, and then you can go from there. And when you open it, you get this screen that shows all the COM ports on your computer. Our sensor's in COM6, is it?
Yep.
So I'm going to choose option 3 for COM6. And then it will connect. It finds out the baud rate of the sensor that you're connected to, so it's 57600, and then it gives you the information about the sensor. So you've got the sensor type, the serial number, and the firmware version that it is currently loaded on. It then gives you kind of 3 options in the main menu. You can install new firmware, download the data, or access a command line prompt. So installing new firmware is something that we've really done a lot of work on lately, because we've been doing lots of firmware upgrades. So this is now dead easy for the customer to do. You just click on one and follow the instructions. It just gives you a few questions to answer. It's very straightforward. It also automatically downloads the firmware from our website, so it's just makes it as easy as possible for the end user. Downloading data again is very straightforward. You click on 2, you'll get the list of all the files, and then you can choose which file you want to download. I'm going to show you the command line prompt, so option 3, where you can access all the menu functions of the sensor. So it first of all gives you the splash screen, and if you notice, the date and time the date is set to zeros. So utils, when it sees that, automatically updates your date and time to that of the computer it's plugged into. You just wait a few seconds, and then you get this updated splash screen with the correct date and time. Okay, now you can type menu, and then you can see all the menu functions of your sensor. So these are split into 3. We have system functions, measurement functions, and data functions. And really, you just need to type in that capitalized word there to access the function. So if I was to type the version, which is the first one, we'll get that splash screen back that we saw before. It really is straightforward, but I'll just go through them in turn. So version is the splash screen. If you type time, you can manually change the date or the time of the sensor. If you type mode, which I'll do, you can change between controlled and autonomous operation, and maybe you can talk a bit more about that.
Yeah, for sure. So for control mode, this is when you're set up to a terminal program or through Modbus, where you can send a scan command, and the sensor will respond to that scan command and start monitoring the pH of the solution. Autonomous is really for remote deployments, or deployments where you don't have control of the sensor for the scan, just a read command or a write command. You just turn on the sensor and it'll start monitoring at its predefined or predetermined monitoring rates, interval delays, and start delays. We have customers that are using both, some on a battery deployment in the middle of the ocean, where they're on a battery, they're in autonomous, it just turns on every hour and takes a measurement and then goes back to sleep.
Okay, so I'll keep it manually controlled for now. Type menu again to go back to that main menu. So that was mode. Baud obviously allows you to change the baud rate of the sensor.
So we do everything from 9600 to 11500, consistent with most telemetry platforms out there, and we have customers using it across the different baud rates.
Brilliant. Interface, I'll type this now. So that allows you to change between Modbus or keyboard communications.
Yeah, so this is again just another different way to talk to the sensor. We now are integrated with 485 Modbus telemetry platforms. We spent a fair amount this first part of this year improving our Modbus structure. It's all available on the website. All the commands mimic that through the terminal program as well. So you can do write and read commands through the Modbus, and it's working well. We've integrated now into a number of different 485 Modbus telemetry platforms.
It's worth adding actually that if you're in Modbus mode, when you open utils, it automatically takes it out of Modbus mode and back into terminal, so you can talk to it, can't you?
Yeah.
So I'll keep in terminal for now. Go back to menu, and we're back here. So interface we just did, that's the Modbus or keyboard. You can change the Modbus address.
Yeah, so all their sensors are either 55 or the last two digits of the serial number for their Modbus address. Obviously, there may be a conflict on their existing Modbus system with sensors that are out there, so you can change this yourself.
Okay, a couple of new system functions here, which address kind of if you've upgraded the sensor, which we'll talk about later, and turning the internal memory on and off to save power. But we can talk about that.
Yeah, you're getting a sneak preview of what's to come in a release, which is planned in 3 weeks' time. So this will be available in 3 weeks' time in a future release.
Okay, so let's look at the measurement functions. The first one is immersion. So each sensor comes with an immersion sensor on it, which you can enable or disable. The immersion sensor means that the sensor will only start scanning if the transducer is immersed in water, which is useful for when you're testing the comms on the lab bench, for example, or for other customer applications.
Yeah, for sure. Obviously, this is a power-saving system. It allows the sensor to be deployed in sort of wet-dry environments, such as dry riverbed, wet riverbed monitoring, estuarine conditions where the tide might go in and out. We also see it being used for when it's put to other sensing platforms next to a multi-parameter system. They can use this to say when the whole multi-parameter system needs to be switched on just by testing it on our sensor.
Yeah. I think this goes on nicely from what you said earlier about the sensor storage. So the glass electrode obviously has to be kept in the storage conditions, doesn't it, to keep the reference protected, whereas our sensor can be left dry, and with the immersion sensor will work when it's running, but it's no problems if it's left dry.
Exactly, yeah.
So, yeah, it's a big differentiator.
Definitely.
Okay, so now we've got profiling. This is another new command which allows you to get quicker measurement, not quicker measurements, but you can see the change you can see quicker changes to pH.
Yeah, so this is if you're in a profiling condition. What we've done here is basically monitor rapid changes in pH, as Kate said, going across a volcanic CO2 vent or monitoring different events within the ocean.
Yeah, so you get the same amount of measurements, but it's a quicker reaction to the change.
Yeah.
Interval allows you to change the time delay between measurements. So if I click on this one, type this one in, you can put 3 zeros in, which is just continuous measurement, or you can choose an interval between 15 minutes to 240 minutes.
Yeah.
And in between the measurements, it goes into its low power mode.
Yeah.
Perfect. So I'll keep it on continuous for now. Go back to menu. What have we got next? Then we've got the scan commands. So we've currently got scan O for higher salinities and scan F for lower salinities, which we're going to be working on combining. But for now, we've got O and F. You just simply type in scan O or scan F, depending on your water, and the sensor will start to scan. We've got a couple of other functions there if you just want a single result back. Again, that's a power saving feature, isn't it?
Yeah, so the scan 0102 commands. Scan 01 is if you're doing measurements greater than an hour and you have full control of the sensor. And 02 is when you send it for less than an hour. Measurement intervals, again, turning the sensor off and on between those measurements. We have customers that have put it on platforms where they send the scanner, turn the sensor on, send the scan 01 command, wait for the pH to be returned, and then just turn the sensor off. And then they can configure it whether it's in an ocean or a freshwater environment, as the cutoffs are shown there.
And then the last two measurement functions are stop and shut down, which speak for themselves. And then we've got results, which if we type results in, you'll see the list of files on the sensor, and you can choose whichever one you want to download. You can also do the same thing on utils on the main menu, if you remember from the beginning. If you choose option 2 from the main menu, you'll get to the same place. So hopefully that shows that the sensor is really easy to use, to set up, to change kind of the measurement parameters. And maybe now we can show the
demonstrations.
Yeah,
why not? So so we're going to just show you the output stream that you get from the sensor and the graphical user interface. We've got 2 sensors set up today, one in an ocean environment, one in a fresher water environment, just to show you the difference in the ONF scan systems that you get and the outputs that you get from each scan parameter. So we do the ocean saltier solution first. And this has been going. So this is a conventional output string through the terminal program, the utils program. We have a $A and B, identifying it's an A and B sensor, a checksum. We give the date and the time, the pH of the system, the temperature. The 99.99s you see next are conductivity and salinity. These, because given as 99.99s, because they're outside the measurement range of the sensor, we cut off around 7 ppt. The concentration of salt in that solution is nearer to 30 ppt, so we default to a 99.99. The 2 zeros that follow those are around the transducer and sensor health diagnostics, and we'll go into the transducer health in a few minutes' time. 55 is the Modbus stress of the sensor, and the 408 is the data that all the file name or number that all the data is being saved to internally within the sensor. So the SD card is switched on in this case.
Perfect. And you forgot to mention the 3rd 0, which is the future.
Yeah, the 3rd 0, we try and find this one. The 3rd 0 is a reserve byte. Obviously, part of our development is to add extra functionality to the sensor as we move forward into the coming years. We put that in there now, so when we release these upgrades in the future, it won't be a pain for already integrated sensors and telemetry platforms.
Brilliant. So now maybe we can go a bit more into the health number, because that's another differentiator between our technology. Okay. So here's the sensor output that Nathan just went through. All of this is on our user guide on our website. But Nathan just went through all this and the CRC. The displayed pH values, again, if it's outside the range, then you get the 99.9s. This is the kind of main subject next, I think, the transducer health.
So because we're not a potentiometric glass pH measurement, we do a lot more detail in our measurement cycle and take a lot more information from our measurement. We can actually understand how the sensor's performing in real time and provide this as a useful output to our customers, and then they can have a bound on the accuracy of the sensor as it goes through the different health outputs. 0, as you saw on the one that we have running in the tank, means it's a perfectly healthy transducer and it's all working well. As that health number rises from 1 to 2, this tells us that the sensor will need some sort of maintenance or abrasion, and I'll go through how we abrade the sensor in a few minutes. 3 shows that the transducer needs replacing. Again, I'll go through how we do this in a few minutes. The 4 is an immersion. When the sensor is first powered on and the scan command is sent, or it starts its measurement routine, if it's in autonomous, it will immediately detect to see if it's wet or in the water. If it's not, the number 4 will be returned in the health number straight away, and the sensor will immediately go into sleep mode.
Perfect. Okay, so do you want to do the abrasion?
Try to. Yeah.
Sharing.
Go to the video. Okay, so if you see a 1 and most definitely a 2 on your transducer health, that tells you the sensor needs abrading. There's a much better video on the website than I'm going to show you now, as I'm going to show you quite quickly. All you have to do is take your sensor, you look at the top face of the transducer, the bit that's sat proud. We put 2 Sharpie dots on the top face of the transducer. We get our abrasion pad, which comes with every sensor that we send, and you just abrade the top surface of the transducer. The abrasion pad is just some really wet and dry paper. You just abrade the top like that until your black dots have disappeared. You can then put another 2 Sharpie dots on there and do the same again, and your transducer's ready to go again. This can be done in dry or wet conditions, so it can be done on the bench or actually in a deployment. There's no issues. We've had people send divers down to abrade their transducers in situ, and that all works really well. So if you're thinking about it, you could even put a mechanical abrader on the front of the sensor in the future and actually do this as part of a mechanical abrasion, similar to the way you would wipe an optical sensor.
Good. And how often do you have to do that?
You have to do that every 15,000 measurements, which in continuous is around 5 days, every 15 minutes is around 52 days, and every 1 hour is around 200 days. So
good memory.
try to. And then periodically you will see a number 3 come up on the transducer health. So you can actually replace your transducer. This is easy to do. You do this after around every 20 abrasions. So if you think about multiplying out your 15,000 measurements, you actually get quite a lot of measurements before you have to replace the transducer. There are videos again on the website to do this, but basically the sensor as fitted comes with a clip which is screwed down. You undo the screws, you pull off the clip, you get your transducer extraction device, also known as a bottle opener, and just gently prise the transducer out. You just pull it out from the sensor, just like that, a little bit of force, and that's removed. All their sensors, transducers, are made in factory. They're all checked before they leave the factory, and all have the same calibration. Therefore, when you get a new transducer, you don't need to calibrate or do anything with it. All you do is take it out of its packaging, line it up with the key on the sensor, and gently push it home. You'll hear 2 clicks as it goes through its O-ring seals and then pushes directly into the electronics board. And now that's ready to deploy again.
Perfect. Perfect. Okay. So now we'll go on to the GUI, the user interface. So the user interface can be downloaded free of charge from our website. If you go to the support section, you'll find the GUI link there. You can watch a demonstration video and you can download it. And once you've downloaded it, you just unzip it onto your desktop and you're good to go. And this is it. So you basically choose your COM port. We're running, this is our freshwater sensor, isn't it? So we're running from COM 4. It finds all the details of the sensor, gives you the transducer and sensor health. So at the moment, it's all running, so all the numbers are 0, basically, is from Nathan's description. So the status bar is green. If there's a problem, then it will go to red, so it's easy to see. And then it gives you the pH, the temperature, the salinity, and the conductivity of the sensor output. You can see these kind of like sausage strings, and basically the bits where there's no measurement is where it's doing the reference check, which is the reason that the sensor can be calibration free. So this, I'll just go through these buttons to show you. You can change the date and time here, or change the measurement interval. So we'll keep it on continuous, but you can change that there if you wish. This one allows you to change the user interface settings, so you can turn off some of these graphs if you're not interested in them, and you can also choose limits. So if I show you here, if you can see these green lines, these are the limits we've set between 6 and 9, and if the pH goes outside there, you'll get an alert. So here, for example, is one for the temperature. You get this kind of red alert warning sign, which says the temperature is outside our predefined limits. So hopefully it's like a really visual way, a really nice way of looking at the data. This button here is the log output. So you can see all your data there if you wish. And then we have start, stop, and shut down, which speak for themselves. We've had lots of really good feedback on this user interface.
Yeah, definitely. Yeah. That's been really good.
Okay, so I'll stop sharing. Maybe you can go through all the other bits, because that's the sensor, isn't it?
Yeah.
Most of the sensor features.
Definitely. So Kay showed you all the free bits. We do some optional extras as well. We obviously do the data transfer unit, which is a really nice way of just connecting the sensor straight to the computer through the USB port of the computer and configuring it. You don't need to buy one of these per sensor. One of these will do a batch of sensors, and indeed you can connect multiple data transfer units to the same sensor, computer, and run multiple sensors from the same computer. We obviously have spare transducers. When your transducer needs replacing, we do spare transducers. That's nice and easy. We have a flow cup. So for flow conditions, such as in well boats, you can basically connect it in, put your flow in, the sensor will slot inside here. This is rated to around 10 bar pressure on a flow line. We can look at doing higher pressure ones in the future. That's certainly on one of the things that we're going to look at. For those guys that are looking at battery deployments, and they can run it off a lithium-ion battery, we do an intelligent battery monitoring unit, which looks at the voltage of the lithium-ion battery to make sure it doesn't go below its discharge voltage in deployment, and will cut off the sensor. It also halves the power consumption of the sensor, so you get nice long lifetimes when you're actually deploying the sensor. And it backs up and saves all the data from the sensor on an internal SD card, and it's easily retrieved. You just pop it out the canister and take the SD card out, and you can just download the data straight to a computer. And for those types of deployments, we're looking at a 28 amp hour battery. We get around 60 days of deployment on a 15-minute interval. And we can, if you put two of those together, you can get up to 120 days-ish on a 15-minute interval. So you get quite long lifetimes now with the new intelligent battery monitoring system.
Brilliant. So talking about integrations, we could just run through some of the integration stories that we've got.
Yeah.
If I can share the right screen, 1 second.
So yeah, so as we've been going through sort of A and B sensors and testing the sensor, we've been testing it at various locations and with various partners. I appreciate some of you know we've been around for quite a while now. These are some of the trials that we've done. Most notably, I think, is the one up in the top corner with the University of Barcelona, where we had two sensors in the water. The one on the right was deployed as a control. It wasn't switched on at all during the deployment, and we were looking at biogrowth on the front face or around the actual sensor without it being switched on. You can see there's a lot of biogrowth on that sensor. The one on the left was actually switched on and measuring during that deployment time. It's around 6 weeks this was in the water. You can see there's no biogrowth on the transducer surface, which is great news. As part of the measurement itself, it generates a small amount of peroxide, a bioagent, which then allows it to keep the transducer clean. This is quite unique, I would say, compared to glass electrode systems and other pH sensing systems that you might use in the ocean, and it keeps it clean for the lifetime of the deployment. And it is a natural product. The peroxide also breaks down in the water quite quickly, so you're not contaminating the water as well.
Takes a long time to change.
It does. So during the course of the last year, we've been working with a number of customers. We're now integrated onto an underwater vehicle with Alzimar on their Alcon AUV, alongside a number of other sensors, and they're looking at monitoring of CO2 across volcanic subsea volcanoes. EWS, we've put it onto their 485 Modbus system, so we're communicating through that 485 Modbus system. Seasignum is quite interesting. They do wireless data communication. So Air Sensor has been connected onto their EM2 system through their 2.3 terminal communication program, but then that's all deployed subsea. They then transmit all the data wirelessly to their surface buoys, and then they can transmit that off to the web. So this is quite a nice wireless integration. We've been placed on the EcoSub as a small sensor that goes in the nose cone of the EcoSub there. We've worked with Metasphere on 485, integrating it onto their platform, their 485 Modbus protocols. And also on the Slocum glider, we've written firmware which mimics that of an integrated CO2, previously integrated CO2 sensor, and we output pH where the CO2 is. That firmware is actually, or that code is actually in the current release firmware, and we can tell users how to access that as well.
Cool, so moving on to the future plans for the sensor. The good news is that all these future plans only involve a firmware upgrade.
Yeah.
So although it's a lot of work from our end, it's not much work for the end user, which is the idea, isn't it?
Yeah.
But yeah, the coming soon firmware is going to have a lower salinity operation.
Yep. So this is going to currently a version 9, which is on the website, cuts off around 0.3 ppt. Lower salinity is going down to about 0.05 ppt. You saw a sneak preview on the menu earlier. along with the profiling mode, which again you saw as a sneak preview. Kay mentioned sort of the sausage shape on the GUI and the downtime in the measurement due to doing a reference checking or reference checking system or validation. Obviously, that makes us unique and it makes us calibration free, but it does mean there is always a little bit of downtime when you're doing your measurements. We're always trying to speed that up, and I was saying in the next release firmware that is being sped up quite significantly in the ocean water scanning. We also know, and this is not for the next release, as you've seen, for the one after that, that having scan ONF commands is difficult, especially in sort of estuarine or solutions where the salt solution may change quickly. We are looking at combining the scan ONF into a single scan command. So all you do is turn the sensor on and it auto-tune itself to the environment in which it's in. That won't be in their next release, but it'll certainly be in the release after that one. Currently, all our sensors only work through 232 bootloaders. We are now starting to look at a 485 bootloader to allow us to do bootloading through 485 comms, and that'll be available in the coming months.
Yeah, so I think it's fair to say that most of the future plans are to make the sensor smarter, isn't it? Make the power less, the sensor smarter and easier.
Smarter and quicker as well. Quicker as well. We're going. Yeah.
There's lots of feedback for the end user with the health number. Yeah. So just to make it, completely worlds apart from the Glass Probe, really.
Yeah, exactly. And a number of these plans here have been developed through working with customers and having customer interactions where we can improve it, and as Kay said, make it quicker and smarter. So we really appreciate the feedback that we get from our customers, and we are pleased to see it going out to multiple platforms now and being used.
Yeah, it's come a long way. Yeah. Okay, to get more information, I showed you before, but if you go to our website, the user guides are in that support section. You can also find some frequently asked questions and my GUI download. The utils program is available for download from the user guide. And then obviously the question on everybody's lips is where you can buy one from. We have a sales tab on the website where you can contact us directly. Or if you find your country in the list, we have a really great network of distributors and resellers that we work really closely with them, and they'll be very happy to help you.
Definitely, they will. Yeah. So just to summarise, this is really quite a few points in this slide here, but we are calibration free. We do give pH, conductivity and salinity and temperature as a calibration free measurement. I hope you can see it is easy to use. There's a lot of configurations that you can do with the sensor to make it easily deployable for different environments and use cases. Our anti-biofouling is unique and it is a byproduct of the measurement, so you don't need to do anything to get that to work. We work from 0.3 to 40 ppt and we're opening that out to 0.05 up to 40 next. We're easy to store, don't need to be stored wet, so there's no need to remember to take your storage cap off the sensor when you deploy it. You just chuck it in the water once you're connected. We log our data internally, and we're a digital sensor at the moment as it stands. The sensor's intelligent, it's disrupted. We've got around 9 patents filed on our technologies across the globe now, and it is affordable as well. There is a significant cost saving not having to calibrate your sensor during a deployment.
Perfect. So I think I've covered everything that we wanted to cover.
Yes, I think so.
How long did it take us? Not very long. Well done.
Thank you.
So yeah, if you've got any questions, please type them in the Q&A. I'll stop sharing now. I think there's a couple. I can't see that far away, Matt.
Yeah, so the first one I think you answered about the biofouling.
Yeah.
How do you deal with that? And the second one is it possible to measure in wastewater?
Yeah, we'll give it a try. Yeah, for sure. No, we can see that that's definitely an area that we're moving into. So we start very much on environmental water monitoring, but now we're going into sort of the dirtier media. So this is definitely a technology you can take.
Perfect. Current lead times?
So yeah, our lead times at the start of the year were around 16 weeks. We're around 8 weeks now, and we're looking to reduce that in the next sort of 3 or 4 months down further again. So we're making progress. We manage our stock quite carefully, being a small company. So we're making sure that we've got good access to all the components that we need on our lead times.
And how does the warranty work?
So the sensors and the DTU have a 24-month warranty. The transducer is a little bit different. I think it's 10,000 scans. I've got it written down here. 10,000 scans or 90 days. And the battery packs are 12 months.
That's good. I think that's all. Yeah, it's true. Distributors hold stock of the sensors, so they're easily accessible through our distributors.
Perhaps we should say we've got a particularly nice one in Iceland. Should we say that?
What is the cost of the replacement transducer?
So this depends on the transducer that you require. For shallower water ones, it's £250. For deeper water ones, it's £500.
And then what is the cost of the sensors as well?
So the cost of a standalone AQ5 is £1,550. The OC300 is £3,500 or £3,025.
Yes.
And the deepest one, the OC1250, is £7,500.
You didn't mention the integration kit actually.
Oh no, I didn't. No, sorry. One last thing. We do also sell an integration kit for those people that want to build their own housings around it. We're open to selling this as just a PCB set, which we can send you and you can install yourselves. So that's we can work with that.
Yeah. And just quickly, someone's asked about sending the presentation afterwards, but we'll send a link to the webinar afterwards, so you guys can watch it back for any information.
That's fine. If anyone wants access to the slide deck as well, we can send people the slide deck.
Definitely, definitely. And always open to have meetings with anyone. If you want more information, just get in touch. And we're always happy to talk to customers.
Yeah, exactly. Any feedback's welcome.
But one last question, do they work in wet soil or concrete?
Wet soil, it can work in wet soil, yeah. Concrete, so for cement setting jobs, we do actually have sensors now being deployed on ROVs, looking at subsea cement setting. So that is an application. It's one of the reasons we put the profiling mode into the sensor so they can capture those pH changes quicker. We do lose accuracy above pH 10, but we can still detect that we're above pH 10 for those types of applications. Perfect.
Okay, so there's one more, I think.
That's fine.
Okay, that's good.
That's great.
Well, thank you very much. Please get in touch if you need anything from us or any more information. Thanks a lot for joining. And as Matt said, he'll send you the link to the webinar so you can watch it all over again if you want to.
Exactly. Thanks, everyone.
Thanks.